Okay, so now that we have looked at the matrix method to find out the solution of the unknown variables x, y, and z, let's see how to use Cramer's rule for this purpose. Cramer's rule is even simpler. So using Cramer's rule, we know that x equals 1 over determinant of A times this substituted determinant, and let's see what we mean by this substitution. So AI, so the ith element for which you are trying to find out the solution of this system, that column needs to be replaced by the right hand side matrix. So in this case, x is the first unknown variable that we are trying to find, which means your first column needs to have the values of the B matrix. So that is 11 minus 3, 0, and the rest of the A matrix stays unchanged. So that is 7 minus 3, 25, 1, and minus 6, 2. And determinant of A, since I've already calculated it here, I'm going to use that value, 1 over 302. And again, if I'm looking for a shortcut or to save time in your exam, find any row or column where at least one of the elements is 0, preferably more if you can find that, and use that to expand the determinant. So let's expand by this column. So it's 11 times 50 minus 6 of 56 plus, so minus of minus 3, which is plus 3 times, so the cofactor of this, so 14 minus 18, so minus 4, which again works out to be 604 over 302 equals 2. What this really shows you is how identical these two methods are. It's merely a difference of notation or representation, but eventually the operations that you're doing are pretty similar, and they clearly end up with the same kind of results. And similarly, you can do it for y equals 1 over 302. Now since you're doing it for the second element, the second column needs to be replaced, so let's put that down first. 11 minus 3 is 0, and the first and third column of matrix A remain unchanged, and you can show that this is 0, and the last one is 1 over 302. The first and second column are unchanged, the third column becomes this one, 11 minus 3, 0, and this works out to be minus 3. So exactly same results with nearly the same amount of effort. Note that for both methods you still need to calculate the value of this determinant A, and it's a matter of practice or perception. I personally prefer this method because there's only one more determinant you need to calculate for finding the values of each unknown variable, but this method works equally well, and especially for certain cases when it's easier to find out the inverse of matrix A, this method may be faster than that method, but it's up to you, and do make sure to practice both methods equally well. So with that, the chapter, most of the important concepts have been covered here, and there will be a separate session on taking some worked out examples and solving them together, so you get more practice on how to actually use these techniques to solve problems for your exam.